Hello friends, I welcome you all to my channel. This video is part of the playlist Let's Solve Mathematics Class 12 from the textbook Objective NCERT at your fingertips. In this series of video, I am trying to discuss and solve problems from the textbook NCERT at your fingertips on the chapter Integrals from Class 12. I have already made 6 previous videos on integrals. If you have not watched them, I highly suggest you please go and watch those videos. It will help you. In this video, I will discuss about how to solve the special form of square root of a square minus x square and square root of x square minus a square using integration by parts. This is only required if you find difficulty in remembering the standard results of this special form. So in that case you can quickly solve it, get the result by using integration by parts. That is what we will discuss in this video. So let's get started. Okay, so we will solve these two special form, square root of a square minus x square and square root of x square minus a square using the integration by parts. I have written down the formula of the integration by parts, where you solve integrals of the form fx into gx, as the formula is this equals, the integral equals fx multiplied by integral of gx minus integral of derivative of fx and multiplied by integral of gx. So let's quickly see how we can use this integration by parts to solve the first special form. So how do we solve? Now there are certain convention which function to choose as fx and which function to choose as gx. There is a convention by the word eyelet, which I will discuss, will not discuss in this video, but I will discuss in some separate video in the future. So in this special form we have only a one function. So the second function we can take it as constant 1. So we will consider fx as the square root of a square minus x square and gx as 1. So by integration, so using the integration by parts, this becomes square root of a square minus x square integral dx minus integral of derivative of the special form, which will become minus x square root of a square minus x square, and then integral of gx, which is 1 in our case. This is what so this is we get. Now the first one is easy. Integral of dx is x, so we get x into a square minus x square. Now the second term, the derivative, so we get again the integral of dx is x, and so we have minus x square by root over a square minus x square dx. This is x into a square minus x square plus we have x square by square root of a square minus x square, and we will write x square as x square minus x square. So we have this. Okay, now let's try to solve this. Let's call it I1. So now we are solving I1. So I1 now becomes integral of a square dx by square root of x square minus a square minus x square, and over here we have in the numerator we have a square minus x square, and the denominator we have square root of a square minus x square, which becomes square root of a square minus x square dx. Now over here the second term is again back to the original integral that we are trying to solve, right? So if we say this as I, let's call it this as I. So this, and now the integral of 1 by square root of a square minus x square, we have a standard result which we need to remember. It's short, it's not that complicated. This is so we have if we take out the constant term a square, we get this, and this is basically again I, which we are trying to solve. Now this is integral of 1 by square root of a square minus x square is sine inverse x by a, and and we over here have minus I. So what we get is I equals to so we get I equals to x into square root of a square minus x square plus I1, which is a square minus sine inverse x by a and minus I. So from this we get twice of I equals to x square into square root of a square minus x square plus a square sine inverse x by a. So this implies finally we get the result as x by 2 plus this, we got the final result. So we get the result as, so this is the result for square root of a square minus x square using the integration by parts. So in case you do not remember, you can quickly solve it using the integration by parts. Now let's see how do we solve the other special form, which is square root of x square minus a square. So now let's solve square root of x square minus a square using integration by parts. Similarly, in the same way, over here we will take fx as the square root term and the gx as 1. So let's call it I. So I integration by parts becomes square root of x square minus a square integral of dx minus derivative of square root of x square minus a square is x by x square minus a square, and over here we have dx. So this becomes, the integral of dx is x, so this becomes x into x square minus a square. Now over the second term becomes, again over here integral of dx is x, so it becomes x square by square root of x square minus a square dx. The solution is very similar to the previous one. So if we call this as I1, so I1 is I1 equals x square by square root of x square minus a square, which we can write it as a square x square minus a square plus a square, and in the denominator we have square root of this. Now if we split it, we get again back to the same original integral, this, and we have this. So this becomes I, the original integral, and this one, the second one, is 1 by square root of x square minus a square. There is also a standard result for this. The standard result is log x plus x square minus a square. So the integral of standard result of integral of 1 by square root of x square minus a square is log mod of x plus root over square root of x square minus a square. Okay, so now we get, if we put the value of I1, we get, this implies I equals to x into x square minus a square minus I1, which is I plus a square log x plus x square minus this. Okay, so this implies twice of I equals to x into square root of x square minus a square, and we have over here a square log e x plus square root of x square a square. So this implies the final result we get is x by 2 x square minus a square minus a square by 2 log mod we get this result. So for square root of x square minus a square we get this, and for square root of a square minus x square we get this one. So it's a little different. The second term in one case is sine inverse x by a, and the second term in the other one is log. So it's quite difficult to remember all the standard forms. So it's better that you know the integration by parts and apply it quickly to solve to get the standard results of these two special form. Now please note that in the actual problem you may not get an expression of the form x square minus a square. It could be something like x plus minus alpha square minus a square. So to understand that, let's quickly solve a problem. Let's say if we solve a problem, this is x minus 3 and 5 minus this. So the main task is to convert the quadratic expression. So this is a quadratic expression inside a root. So the main task is to convert the quadratic expression in the form x square minus a square or a square minus x square, or it could also be a square plus x square. So let's see if we try to convert this. So let's try to do it in a roughly see what this quadratic equation is and how it can be translated to one such special form. So this is 2x minus 15 minus x square. Okay, so definitely it will be of the form a square minus x square, since the coefficient of x square is minus 1. So if we quickly try to, so we have x square minus 2x. So definitely to form a whole square, we must have 1 by over here 2x. So this will definitely be 1, and to compensate the minus 1, we need to have plus 1, and already we have 15. So this becomes 16 minus x plus 1 whole square. This is basically 4 square minus this. So we have the form a square minus x square. Not exactly a square minus x square, we have x plus 1. So now I will not solve this again using the integration by parts, because I've already solved it. So this becomes 4 square minus x plus 1 whole square dx. So if you do integration by parts, this is of the form a square, the first one, that is the square root of a square minus s square, and the result we got, this form, the first one, for that the result we got is we got this result. So I am simply copying it. If you do integration by parts, you will have these results, but remember that over here we have x plus 1. These standard results which is being highlighted is for square root of a square minus x square, but if we have x plus 1, but that is not a problem. We can replace this x without any issue by x plus 1. We can say this is x plus 1, and also okay, let's skip this. I will keep it as a reference and I will write the result. So the solution to this integral will be where a is 4, in this problem a is 4, and we will have to replace x with the x plus 1. So the solution will be x plus 1 by 2, and this is inside the square root we have the entire quadratic expression which is there in the original problem. So I can say this is let's say I can keep it like this, the original one, x minus 3 and 5 minus x, 5 minus x, and over here a square by 4, and a square is 16. So 16 by 2 sine inverse. Over here we have x plus 1. So x plus 1 by a is again 4. So this will be the answer for this problem. So I hope this video was beneficial. This video was about to let you know that if you are required to solve an integral of the form square root of, inside you have a quadratic expression like this. I'm talking in general, and if you and if you can rewrite this quadratic expression in the form either a square minus x square or x square minus a square, then you can use to solve the integral, you can use integration by parts. If you remember the formula for these two special form, then it's fine, but otherwise you can use the integration by parts and solve it. And yes, so that is all for this video. If this video was beneficial, then please like it, share it with your friends. And if you are watching my videos on regular basis and not yet subscribed, then please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. In the next videos, I will try to discuss the integration by parts in more details and try to solve problems on integration by parts from the textbook of Objective NCERT at your fingertips. So please stay tuned until my next video. Thanks for watching, and until the next video, take care and bye.